Hi again, Mr. N here, still working on the proficiency exam. Everybody, problem number 29 in front of you deals with volumes and everything that spins around the volume of a cylinder and the cone, right? And the problem says the cylinder and cone shown in the diagram below have equal volumes and equal heights. Very important. Equal volumes and equal heights. What is the ratio of the radius of the cylinder to the radius of the cone, right? And we can name, let's say, the radius of the cylinder lowercase r, and the radius of the cone capital R, right? So I will know that lowercase r would be the radius of the cone. I mean backwards, right? Hold on. So the radius of the cylinder, lowercase r, the radius of the cone, capital R, big R, and I'm looking for what? The ratio of the radius of the cylinder to the ratio of the cone. So I need to find what is that R, lowercase r over capital R, right? And you have the four options, obviously. 1 to 3, 3 to 1, 1 to square root 3, square root 3 to 1. And you guys know that the column here in math, if I have 1 to 3, that's nothing else but 1 over 3. And this one is what? 3 over 1. This one will be 1 over square root 3. And this one will be square root 3 to 1. Okay? So how should you approach this problem? Well, first of all, you need to know how to find the volume of both of these geometrical solids, right? Geometrical shapes. And as I have told you so many times, the proficiency exam gives you a page that's filled with formulas. Let's see if I can show it to you here. You see, if you go, it's either in the front or at the end of your test, you will have this page with all the formulas that you will be tested on the proficiency exam. As you can see here, I got the cylinder and the cone. So if you don't remember this formula, don't give up. The formulas will be given to you either at the beginning or at the end of the test. So go and look for them, okay? And I have already done that. I have them here. And these are the two formulas. Hopefully you guys can see them. Okay. The volume of the cylinder is the area of the base, which is your circle in this case, multiplied by the height, right? The volume of the cone is pretty much the same. The area of your base, the circle, multiplied by the height. However, you're taking only 1/3 of that, okay? And let's go back to our problem. The problem says that they have the same volume. So what I'm going to do first is to write the volume for your cylinder. And the volume of your cylinder, if you remember from the formulas I just shown you, are what? The area of your base multiplied by the height. But your base is a circle with the radius, what? R. So the volume of the circle will be pi r squared, right? That's the area of any circle with the radius r, multiplied by the height. And this is the volume of the cylinder. Let's write it V sub psi. Okay? Now, what is the volume of the cylinder? Well, what I said. It's pretty much the same thing. Pi r squared multiplied by the height, right? So I'm talking about the area of the base, which which is a circle, pi r out of the cylinder squared, right? Multiplied by the height, and you have to divide this one by 3, because otherwise you will have a cylinder with that circle, with that radius, right? And the same height. So divided by 3, and this is the area of my cone. Let's write it down as the volume V sub cone, okay? And the problem says what? They have equal volumes and equal heights, okay? So from the problem, I can write that the volume of the cylinder equals the volume of the cone. Very important. What should be the next step? Well, the next step is to substitute, instead of the volume of the cylinder, the formula that we just found, right? So it will be pi lowercase r squared times height, and that should equal the volume of your cone, which is here. What is the volume of the cone? Pi r, capital R squared times the same height, because we said they have the same height, divided by 3. Okay? Well, we have an equation in r, lowercase r and capital R, and we have to solve to find what is the ratio of r to, lowercase r to the capital R. In order for us to do that, I can simplify the whole thing, because I know pi and pi are the same. So how am I doing that? I'm dividing everything by pi, right? I'm dividing the left side by pi and the right side by pi. Nothing changes, the equation will stay the same. Then I have h and h, the same height, so I can divide both sides by height, and this will cancel my height. And your expression now looks like this: r squared equals capital R squared over 3. Alright? Well, I need to find what is the ratio of r over r squared. And what I can do here is I can divide everything by r squared. Or if you want, I will multiply both sides by 1 over r squared. R squared and r squared here will cancel out. And on the left side I have use put a line here. I like the chisel term. Okay, so I have on the left r squared over capital R squared equals 1 over 3. Well, some of you may be in a rush and will just go ahead and say, yeah, the answer is A, but that would be wrong, because the problem is asking me to find what is the ratio of the radius of the cylinder to the radius of the cone, not of the square of the radius of the cylinder to the square of the radius of the cone, right? So we need to find what is r over capital R, not what is r squared over capital R squared. In order for you to do that, you will need to get the square root. Well, the square root of this side, right? You're basically taking the square root of both sides of the equation. And we can do that here because we know these are positive, so we'll have no problems in dealing with negative values. And we have what? What is square root of r squared over r squared? Well, that's r, lowercase r over capital R which equals what? Square root of 1 over 3 is actually square root 1 over square root 3, but we know that square root 1 is actually 1 over square root 3. So looking at your possibilities here, which one is the right answer? Well, the right answer for this particular problem seems to be C. The ratio of the radius of my cylinder, lowercase r, to the radius of 3. Well, obviously, the base of your cylinder has to be bigger than the base of the cone has to be bigger than the base of the cylinder if they have the same height and the same volume, because just look at the formula, right? The formula for the cone is pretty much the same, but you have to divide by 3 all that pi r squared h. Okay, and this is how you answer similar problems involving cylinders and cones. These are the steps you have to take, and remember, the formulas are in that test booklet, right? Look for them, use them, make sure you're copying them right in your paper, and everything will be good. Proficiency exam, here I come.